know, you guys got to soak it in. You guys only get so much more time with me. You know, like no, you won't have me, buddy. You don't get me again. Trust me, I'll be waving at you. This is Naples class over there. If you don't do something cool. What was I gonna say? Oh yeah, we only have we got 2 4-day weeks and 3 5-day weeks. That's 5 weeks, and then it's spring break.
What?
I know.
No, like I didn't understand.
We have 2 4-day weeks this week and next week, and then there's 3 5-day weeks, and then spring break.
That's when the quarter ends, not quick.
I know, just like that.
That's when the third quarter ends, right?
Yeah. Well, it actually ends the week before that. Yeah, the week before spring break is the last of the 9 weeks. We actually have 1 week before spring break that's included in the 4.
Spring break's a week off.
Yeah, it's just the way it fell with the end of the year and everything. But then we have testing in April, which is gonna throw us all off, and then
we just got them.
Exams in May.
And the exams in May.
Do you know what day we got tested in April?
Yeah, basically this we actually did just get sent the testing schedule. I believe it's either the Tuesdays and Thursdays or Tuesdays and Wednesdays in April that we have testing. Now the nice thing is that for you freshmen, you guys only get tested in Algebra 1.
Okay.
No,
that's not good.
As a sophomore, you will get tested in English, math, social studies, and science.
Why?
So bummer. But as freshmen, you only get tested in Algebra 1.
But not even English?
Not even English. You do, I think the English tests are 7, 8, 10, 11. I don't know why it skips 9. I don't know.
Or 12.
Right. They don't give any tests for 12th graders just to give you guys the ability to make up tests, if you need it. You know what I mean?
Yeah.
They don't plan any your senior year just in case you fail.
Like SAT and ACT.
Right. And they're assuming that a lot of seniors might be taking AP classes at that point, which should be focused on the AP tests.
Yeah.
But really, folks, we're like.
So you think it's gonna be around the 13th range?
Is there a test on the 13th?
Yeah.
I don't think so because I think they're Tuesday, Thursdays.
Let's keep it that way.
I think the math test is the 19th, 21st.
You should put in a word that not anywhere near the 13th.
Okay,
you should just keep that week.
I'll submit that.
Okay, thank you. Keep that week.
Okay, I sent that in. I sent that in. Because I'm just playing around. All right, let's take a look here. I've got 2a plus b squared. 2a plus b squared. I had somebody the other day be like, Mr. Laverick, whenever I start your videos, I have to skip forward 3 minutes. Yeah, that's about right. 2a plus b squared. Now, remember, if you learn the rule, you can use the rule. However, you can always fall back on foiling, right? Foiling. First, outer, inner, last. First, outer, inner, last, right? So this becomes 4a squared plus 4ab plus b squared. Does everybody follow me there? That, nothing new. That is just foiling. First, outer, inner, last. If you wanted to use the rule, you could. Square the first, double the product, square the last. Square the first, double the product, square the last. Okay, what does that mean? That means if I square 2a, I get 4a squared. If I take the product, 2a times b, 2ab. Double it, 4ab. Last, b times b, b squared. That's the trick. If you don't want to learn the trick, totally fine. You can just foil. Yeah.
That working with calculator. That kind of problem.
You're always asking about a calculator. Basically, you can do none of this stuff in your calculator. It's all variables. You got to just brain. No photo math either.
So if you have 2 variables, is it equivalent to 1 variable to the race of the second?
As long as those variables are the same, yeah.
So like 4ab is like equivalent to 4a raised to the second and b to the second.
I would say no, not equivalent. In terms of degree, yes.
So like you don't have to rearrange it.
Right.
Okay.
Correct.
5 divided by 6. I was like, 5 divided by 6? And he was like, that's not a problem. I was like, 5 divided by 8? Not much. I was like, oh my god. Not one. Well, in 3rd grade, we couldn't get it.
All right, here we go. 4x plus 3, 4x minus 3. Now, why is this a special case?
Because they're opposite signs, so they're going to cancel out.
Yeah, they're opposite signs. So what I can do is just go straight to my answer of, okay, square the first, square the last, put a minus sign in the middle. Yeah.
I have a question to one.
Yes?
Is this the normal form or because b squared?
This is okay. You mean like standard form? It's okay to have it like this because there's two different variables. Yeah. Why would you write this 4a squared plus b squared plus 4ab? Yeah.
Is that wrong?
That's not wrong.
Oh, okay.
No. Honestly, I think it's however you want to write it at that point. Because for standard form, really standard form only applies when there's only one variable. Yeah. Now, 16x squared minus 9. How did we get that? Well, we could just FOIL. 4x times 4x is 16x squared. 4x times negative 3 is a negative 12x. 3 times 4x is positive 12x. 3 times negative 3 is minus 9. And they do cancel in the middle like that. Okay, let's take our binomial times a trinomial. 2x minus 3 times 6x squared times 6x squared plus 7x minus 4. Okay, let's distribute in. 2x times 6x squared, 12x to the third. 2x times 7x, 14x squared. 2x times negative 4, minus 8x. Negative 3 times 6x, minus 18x. Negative 3 times 7x, minus 21x. Negative 3 times negative 4, plus 12. Again, the more you stay organized, the better it is. Yeah.
The minus 18x has a 2.
Ooh, squared. Whoops. Did that last grade too. I always forget those squareds.
Just forget how to
Okay.
do this.
Okay.
Okay.
What is that?
It's a SNL skit.
I know. I thought that's what that was from. I was like, really? The Pete Davidson thing? Okay.
Okay. Nothing.
Not that old.
I'm kidding.
It starts
This is
failing.
left.
Show on Netflix.
What?
Starts like senior tests.
Yeah.
Show you the ball.
You can grow it out and get a mole.
Any questions about that one? No? I will tell you there's at least one of them on the quiz like that. Okay? So make sure that you know how to do a binomial times a trinomial. Some of you guys get really confused with that, and I would say the only issue is probably paying attention to detail. Right? Like I screwed up, I forgot my squared. Right? That would throw off my whole answer, right? All right.
I got that one right.
I also got that one right.
I got that one right. Give him the trophy.
Give him the trophy. Give him the glass bowl. All right, questions on the homework. Are there any questions on the homework? I guess I should say it that way. Because in all honesty, I would hope that the homework was kind of on the easier side, but again, that's up to you. Are there any questions that you'd like to go over? Yes.
Can you go over 13?
13? Sure. 13 here. 2 minus 7, 2 plus 7. Now, if I wanted to FOIL, could I FOIL? Of course. But we can just recognize that this is in that minus plus pattern where it's one's a minus, one's a plus, and everything else is the same. So meaning I square the first, square the last, put a minus sign in the middle. Does that make sense? I could FOIL though. T squared plus 7t minus 7t minus 49, and I'd get the same thing because those will cancel.
And will it always be a minus sign because they're like
Correct. All right, let's get to the notes for today. Notes. We got a quiz tomorrow. What am I talking about? Let's get to the review sheet. Now, I will say this. You know me in review sheets. What would I say about this review sheet?
Exactly like that.
I mean, it's exactly like that's the funny part about like these quizzes. Like I give you the quiz.
And they're exactly the
I mean, I give you the quiz.
It's like close.
That's
No,
literally the test.
no, it's the
literally
same.
test. If you do
I
good,
give you
perfect.
the quiz.
This is great. If you do this one, really,
I mean,
just study all the answers.
take home for you.
Just study all the answers.
I give you
Everything.
Exactly.
You can't. Oh,
You gotta make sure that you know how to do it.
Yo, I got my test. On Saturday. 40 out of 40. 30 out of 40.
No.
No, when you like
I just
The
right.
name's not
No,
good. I can't like the dungeon. I can't get the name.
I failed the first time.
Yeah.
You failed? Yeah.
Yeah, Josh was like trying to do shit, and I was like, you don't even know who that is. Sit down right now.
Like, my hand was like, and I
All right, here we go.
There's a lot of- I didn't
The
say
white boy
anything.
last.
Yeah.
I was like,
And I'll remember that when I'm grading this quiz.
Oh.
All right, take a look at the first 5. I would like everybody right now to do the first 5 problems right away. Go for it. No talking, just go for it. For each one of those, I want the numerical value of the degree. For add the powers of the variable.
Do we just have to find
Yep. Okay, so we should be done with those by now. That should be how quick those go. Okay? If I want the degree of a monomial, what do I do to find the degree of a monomial?
Add up the exponents?
Add up the exponents of the variables, right? So what's the degree here for number 1? 9. 5 plus 4 is 9. What's the degree here for number 2? Oh,
I was gonna do it.
we don't want that.
oh, I missed
Did you shut my door? What's the degree of number 2? Sieben. Sieben. 7. Is that correct? Sieben?
Yeah.
I don't know.
1, 2, 3, 4, 5.
What is that? German?
Language, probably.
What?
That's German, right?
I only know
Okay.
English. I'm sorry.
I don't know any. I know Guten Tag.
What does
Um,
good talk mean?
Good test.
That's about it.
What does that mean?
Hello.
No time German?
What's my degree of number 3?
Zero.
Shh.
One.
Oh, wait, no.
Trust yourself.
0.
The degree is 0.
Wait, I was. Oh yeah, because this number is not a variable.
What's the power on the variable?
1.
There is no variable, so the degree is 0.
I'm sorry. I was right.
Now, for number 4, what's the degree there?
10.
5, right?
5. Thank you. It's the highest degree. Now, what changed about the problem?
It's a polynomial.
It's a polynomial, no longer a monomial, but a polynomial. That's what changed. So therefore, the degree here is 5.
So is the next one 8?
So the next one, now be careful. See, this is what's tricky about the next one. is that I now have to combine everything I know about 1, 2, and 3, and then with 4. What's the degree here?
10.
What's the degree there?
9.
And then here's 1. So what's the total degree?
10.
10. Okay? That one's a little tricky. Because you have to think about, okay, I have to find the degree of each monomial. So I'm pulling, adding up the degrees, adding up the powers for each one, but then pulling the biggest one for the full degree of the polynomial. All right, let's add and subtract. Oh, no, not yet. Standard form still. Yeah.
So every time for the last one, it's just whatever ones come within like the addition.
Yeah. Always looking at the separate terms. Is that what you're thinking? Yeah. All right, let's take a look at standard form and then identifying leading coefficient. Okay, for number 6, somebody tell me, what's my first term here in number 6? Noah?
7x to the 4.
Good, and then what?
3x to the second.
Good, and then what?
Negative 4x.
And then?
Negative 6.
Good. And then what's my leading coefficient?
7x to the 4.
Well, be careful. Take the x to the 4, though.
Oh, 7.
Just 7. Would I take off if you wrote 7x to the 4? Yes. Why? Because I'm asking you to identify the coefficient. And by definition, coefficient is the number out in front of the variable. The number out in front of the variable. Bless you. All right, what about the first term for number 7? What should come first? Negative x to the 6th.
Oh, I don't know why I said it like that.
That's okay. What's the next term then? 5x to the 5th. And then obviously our minus 2x to the 4th is last. Now I want everybody to think about what you would write down for your leading coefficient on this.
You wrote it to the 4th.
Oops. Sorry, I was already thinking to the 4th for the next one. What is my leading coefficient for this? Geo.
Negative 1.
Negative 1. Very good. Negative 1.
Okay.
Negative 1. Questions about that? All right. So let's add and subtract now. Now, what is my rule for addition and subtraction? Essentially, what do? I'm adding. Yes. Put the numbers together. What's that called? Combining like terms. Combining like terms. So in this case, what should come first when I write my answer? In what should be my first term? Good. My r to the third. My r to the third. Remember that you should always put your answer into standard form. And Rose said negative 13 r to the third. Yeah.
Can we solve it in the other way and then put it into standard form?
Yeah, that's fine. I just like to do it all in the same step because it eliminates a step. So combine like terms and put it into standard form. See, now I say, okay, minus 19r, and just keep it in the second position. Now, again, like Gio said, could you have combined like terms on one step, then reordered it? Of course. That's fine. Just make sure it's in standard form when you're done. All right, taking a look at number 9 here. Now, does the plus sign do anything in between these two polynomials? No. So just combine like terms. 9x squared minus 4x squared, 5x squared. 5x.
You're going.
5x minus 7x is a negative 2x. Negative 3 plus 9 is a positive 6. At least on YouTube you could slow me down.
Go faster.
Good. Yes.
No, I really do.
If that addition sign is a subtraction sign, would we be switching?
Well, that's the next problem.
Because I don't understand the subtraction one.
Okay, so you're good with the addition?
Yeah.
Okay. Well, then the subtraction ones should be fine as well. All you need to do at the beginning is distribute the negative. That's essentially all you need to do.
Do you combine like terms
After. See, for addition, I'm just going to go straight to combining like terms. I'm going to act like those parentheses are just not even there and add them. For the subtraction, let's take a look at 10 and 11. For the subtraction, I have to do something with that. I have to subtract. I have to distribute the negative first. Here's what I mean by that. I take this negative and I bring it in here, here, and here. What's that mean? Well, the first polynomial does not change. The second polynomial is the one that I have to change everybody's sign. That positive x to the third becomes a negative x to the third. This positive 8x squared becomes a negative 8x squared. That negative 9 has to turn into a positive 9. Now I can combine like terms. 6 and negative 1 make 5. Negative 1 and negative 8 make negative 9. And then we bring down our plus 9. Am I changing the variable at all when I combine like terms? No. All right, now distribute the next one. Again, I'm just distributing that negative. The left side polynomial does not change. And then we bring down the minus 2y squared, a plus 4y, and a minus 3. We combine like terms. 5y squared and a minus 2y squared is a 3y squared. Oh, that should be a 9y here. Yeah. 9y and 4y make 13y. And a negative 5 and a negative 3 make minus 8. Questions about that one? Okay. Now, we're multiplying monomials on these next two, aren't we? Multiplying monomials. Now, what does that mean? That means I honestly just multiply common pieces together. Just multiply common parts together. Like, for example, we take 7 times 4. We get 28. We take a to the fifth and a to the third. What's my power on a? 8. Remember, we add exponents when we're multiplying with bases. And then we take b to the 7th times b to the 1st, which is b to the 8th. Now, does that change when we multiply 3 polynomials? Do the rules change? No. All I do is just now add one more monomial into the mix. 1/3 times 6 times 8. Okay, 1/3 of 6 is 2. 2 times 8 is 16. Then I've got x squared, looks like another x to the 8th, so x to the 10th. Looks like I've got a y to the 4th and a y to the 3rd, y to the 7th. And I've got a z to the 4th and a z to the 5th, so z to the 9th. Questions about that? Yes?
Can you repeat how you got the 16?
1/3 times 6 is 2 times 8.
Oh, okay. My bad.
So when you're multiplying monomials together, you just multiply all the common pieces together. Look for the numbers, look for the variables, common variables, and add the exponents. Yep.
You go back to 9.
Go back to 9.
Yeah.
I need to keep moving. I can't. I need to keep moving. You can catch it back on the video later. Take a look at 14. What does this tell you to do? Kind of, yeah. Foil, right? It's telling us to foil. First outer inner last. which is essentially just the distributive property, right? So let's multiply. Let's take y times y, our firsts. Y times y is a y squared. Outer. Y times 4y, or sorry, excuse me. Y times 4 is a 4y. 9 times y is a 9y. 9 times 4 is a 36. Add the like terms. Y squared plus 13y plus 36. Yeah.
Wouldn't it be like y, since you're adding the 4y and the 9y would be y too, right?
No. You never change the variable when you're combining like terms. When you're adding or subtracting, you don't change the variable, only when you're multiplying. Same thing for 15 here. Gonna FOIL. 5x times 4x is 20x squared. Outer. 5x times 6, 30x. Inner. Negative 3 times 4x is a negative 12x. Last. Negative 3 times 6 is a negative 18. And now we combine like terms in the middle again. 20x squared plus 18x minus 18. And there's my answer. Again, I know we're kind of running short on time. If the bell rings, I am going to keep going. And so you can just watch the video later. Yes?
Can you do number 20 real quick?
No, you can watch it back on the video. I'll have it on the video. Who knows? I may put a little, like a little smiley face or star thing in the video. Like I sometimes do. You never know. You should watch. See any Easter eggs. But then maybe.
Valentine's Day.
There you go. Maybe I'll tell you to a heart. That's weird, though. Don't put hearts. Okay. That's weird. Not to a teacher. Okay.
Okay.
Personal space. M plus 7, M minus 7. Now, is that a special case? Yes. That is a special case. How do I see that? One's a plus, one's a minus, and they're the exact same thing, right? All right, so that means my answer, I can just go straight to my answer. M squared, and then 7 squared is 49, and I just put a minus sign in between. Could you FOIL? Yes. M times M is M squared, negative 7M plus 7M minus 49. The unique thing about those is that the inners and outers will always cancel each other out, leaving just the first and the last. Yeah.
On the next one, since it's squared, you can just do the same thing
No.
without it.
No. You've got to take G plus 6 times G plus 6. Now, are you thinking you can use the shortcut?
Yeah.
There's the shortcut that you can use, but it's not the same as 16.
Oh, I know, that's what I said, like G2 plus 36.
No, it's not the same. When you FOIL this, you're going to get G squared plus 6G plus 6G. See, it doesn't cancel out in the middle. That's the problem with that. 6 times 6 is 36. So what happens in the middle, remember, this is your other special case. Square the first, double the product in the middle. Square the last. So 6G plus 6G ends up being 12G. There is, yeah. But it's that square the first, double the product, square the last. Square the first, double the product, square the last. Questions about that? Let's do another one of those. Okay? Again, if you need to watch anything back, just watch the video. Okay, here's 18. 6G minus 7 squared. I do G? G's are hard to write. 6G minus 7 squared. All right, first outer inner last. Firsts, 6 times 6, 36 G squared. Outer, what's 6G times negative 7? Negative 42 G. And again, this one and the inners is another 42G. Watch out for that. Negative 7 times negative 7 is a positive 49. All right, combine like terms in the middle. 36G squared minus 84G. See, it doesn't cancel out. How about I do number 20 right now, and then I'll do number 19 in the video, and you can catch up on that. Because we did one like 19 in the warm-up today. Okay? All right, I'm going to jump to 20. Is that okay? Here we go. Here's the issue. Here's why I want to say this to you guys here, because you know what a lot of people are going to do? D to the third plus 5 to the third, and be done with it. Wah, wah. You can't do that. You can't do that. You have to write it out like this. This is the one where we did in the notes on Friday. I know you guys were really excited about the pep rally on Friday. Maybe your minds weren't in it. I heard that laugh. But this is the one where you multiply these together first. Bring down your D plus 5. And that gives you a D squared. And then we got to FOIL this right side here. Gives you a D squared. 5D, 5D, 25. All I did was just FOIL the right side polynomial, which leaves us with a D squared plus 10D plus 25. And now we take a binomial times a trinomial. I know the bell's going to ring on me. I'm just going to keep going. If you want to stick around and watch, I'll give you a pass. D to the third, 10D squared. Just be quiet as I'm going. Plus 25D. 5D squared. Oops, that's a 5. 50D plus 125. And now we combine D to the third. 10 and 5 make 15D squared. 25 and 50 make 75. Guess you didn't need to stick around after all. I will go back for the end of the video and do number 19. So if you want to watch that one. All right, so long, everybody. I'm going to do number 19. Just be quiet on your way out. All right, here we go, folks. So number 19, I'm going to take binomial times a trinomial, multiply in 5x. So 5x cubed. 5x times negative 7x is a negative 35x squared. 5x times 9 is a 45x. Now, I'm going to move over a little bit because we need more room. Negative 2 coming in. Negative 2x squared. Watch out here. Positive 14x minus 18. And then we take a 5x to the third. Oops, not that 45. See, everybody. Minus 2x squared is a minus 37x squared. Plus 59x minus 18. All right, and there we have our answer. All right, so I hope you all have a good day. Study hard on the quiz. No smiley faces, no nothing. Sorry, no tricks.